Welcome everyone to our workshop on creating a MothBot. And so for those of you who aren't really familiar with the Makery, we have weekly meetings on Tuesdays and Thursdays. So it's alternating. So Tuesdays we have our workshops and Thursdays we have our project meetings, and all of those meetings are at gtmakery.github.io/bluejeans. And if you're not already on the mailing list, you can join it with gtmakery.github.io/mailing. And so our workshops are mainly targeted towards like what you guys want to see our workshops on, and so that's why you can fill that out in the interest form. But in general, we have Arduino, Raspberry Pi, different types of circuits, wireless electronics, and even 3D printing and laser cutting. And we also have projects. So actually, this semester we aren't going to be doing a go-kart. We're instead going to be doing a robot arm. So you can join us on Thursdays, or every other Thursday from next Thursday, not this coming one. But we might still have a meeting on Thursday if you want to join. Cool. So to get started with the workshop, you can either download the Arduino IDE if you have an Arduino or you have the rental kit, or you can just follow along virtually with Tinkercad, and you can get that at gtmakery.github.io/tinkercad, and those links should already be in the chat if they are not. Yeah. Okay. And both of these are free. So let's go ahead and get started. Okay. So what we are going to do today is we're going to create a little car that can follow like the brightest source of light. And so to do that, we're going to use something called a photoresistor. And so here, let me grab a photoresistor from this little kit. Okay. Here is a photoresistor. So I'll actually switch the view so that you can see it. So right here, this is a photoresistor. I don't know if it's like focusing in the camera. It doesn't look like it's focusing, but it looks almost exactly like the little picture in the bottom left. And so what I'll do right now is I will just quickly build up a little circuit with the photoresistor. So let me switch over so that you can see the code and what I'm working on. Okay. So what you do for the photoresistor is, actually let me get the slides are not there. Yeah, this one. What? Sorry, I'm not finding a good view for this. Okay. So you can see that in the little diagram, we want to connect the photoresistor will have one wire going to the 5-volt, and then the other end will either go through a resistor and then to ground, or it will go from just that other pin to a signal. So you can ignore this little black thing in the breadboard, we'll get to that later. So I will just put in the photoresistor into the breadboard, and then I will grab some wires. So I'll just grab this red wire and I'll plug it in from the 5-volt in the Arduino. And so let me bring this camera down so you can see more clearly. So that's coming into the 5-volt pin right there. It has a little 5 volts like label. And then this is going to come to one side of the photoresistor. So that'll be right there. And then we will have another wire going into, we'll just use port A1 for the sensor. And that'll come from here. And then we also want to have the resistor. So let me find a resistor. So right here we have a resistor. There. there's the color bands on it. I don't remember the exact resistance on it. I believe it's about 6 kilo ohms. And so then we'll have just coming out of this into another row of the breadboard, and then we'll have one last wire that goes to the ground. So it's coming connected to the resistor, and then it goes into the ground of the Arduino. And so that's all the wiring done. So now let's write in some code. And then let me okay. So right here I can put in so since we want to use an input pin, we'll do pin mode A1 and then in all caps input. And so what this is doing, it's telling it the analog 1 pin should be used as an input pin, and it's just, this should be A0, and that's because if you look at the Arduino, A0 is that first one where the orange wire is plugged in. And so if you're following along on Tinkercad, you should be able to write like the same code and it should work just fine. And so here, what we will do is we'll just do int reading equals, and then we can use a function called analog read, and then just pass in the pin number that we want to read from, and then we want to print it to the serial monitor. So the serial monitor is something you can use. It's similar to like console.log in JavaScript or system.out.print in Java or print in Python. This is just a way to, from the Arduino, to print to a console that you can see on your computer. So we do serial.println and then reading, and then when we want to use the serial, we also have to kind of initialize that. So here we're doing serial.begin 9600 in our setup method. So the setup method will run once at the beginning, and then the loop will run over and over. And this 9600 is the baud rate at which we want the serial monitor to communicate with the Arduino. And so now I'm just going to quickly save this sketch. So I'll just put it on my desktop for quickness. So I'll just call it MothBot. And then now let me switch to a view where you guys can see the serial monitor. Okay. So now if I transition to that, you see it's just printing out like it's just hovering around like 700 or so, right? And now, so what I'll do is, so here you see the photoresistor, and then if I shine a light right over the photoresistor, you can see that the value gets much higher, and then it goes back down, and then if I cover up the light, then it goes down even lower, right? So now we have a good indication that ranges from 0 to 1023. That's just the range of an analog sensor. That indicates like how bright or how much ambient light there is on that sensor. Okay. So that is how the photoresistor works. So now let's talk about the motors. So let me switch back to some other slides. Okay, so here, let's talk about using a transistor to control the motor. So if you wanted to, you could build up this circuit in Tinkercad or in real life, but transistors, they let us control the amount of power that's allowed to flow through the circuit. So if you look at the diagram, we have the power of the motor is coming from the power rail, which is at 5 volts, and then the ground rail is coming from this output on the transistor. So there's two ends of the transistor. There's the source and the drain, and so it's connected to the drain of the transistor, and then the source is connected to ground, and then this white cable is determining essentially like how open that gate is. So this is an N-type transistor, which is, it has an N right there. And so N-types are normally closed. So that means if I apply voltage to this white wire, it'll like close the circuit and it'll allow current to flow from the orange to the black wire. And so you can use that to basically control how much actual power delivery is, or how much current is allowed to flow through the motor, and that'll control its speed. And the reason we want to control current is because if we just control the voltage, that'll also like decrease the torque of the motor. But by doing it this way, we can have a consistent voltage going across the motor, but just vary the current. Okay. So now let's look at something called an H-bridge. So actually, before I talk about an H-bridge, does anyone have any questions? You can just drop them in the chat or anything. Cool. So the way an H-bridge works is it uses a combination of transistors to give you two-directional control of a motor. So right here we have our motor, and you have the positive end on the left and the negative end on the right. And so we have this VCC is our power, and these three lines is our ground. So power is going to flow through here, and then somehow through the circuit, and then out through like the ground wire. And so if we look at the four transistors that we have available, there's two P-type transistors at the top and two N-type transistors at the bottom. So P-type transistors are connected to power. So what that means is they will let power through the circuit, and they are normally open. So in a P-type transistor, if there's no current at the gate of the transistor, then the circuit will be complete. But if you apply a voltage to that transistor, then the circuit is broken. And so the way we control which direction the motor will spin in is by either applying power to both of these or both of these. So let's look at the case where we apply power to both transistor 1 and 2. So this P-type transistor, since we're applying voltage, it'll close this gate, and then since we're applying voltage to an N-type transistor, it'll open this gate. And then on the other side, we have no power here, so the P1 is open and the N1 is closed. So then you can see that the current has to flow through this P-type and then through this N-type, which we opened, and then to ground. So the power is going to flow from right to left on the motor, so that'll make it spin in one direction. But then if we apply power to both of these, this gate will open, this gate will close because the P-type is getting voltage, and then when the N-type gets voltage, it opens the circuit. So this is closed, this is open, and then since there's no voltage, this is open and this is closed. And so then we have the opposite effect, where the voltage comes from VCC, it goes through this open P-type transistor, and then it comes from left to right across the motor and goes through that N-type transistor and then goes to ground. And so you can see that just by changing which side we apply power on, we can spin the motor in a different direction. And so now let's look at the quad half H bridge. So okay, the camera is covering up part of that slide, but what that says is L293D. What do the diodes do? Oh, yeah, sure. So I can have my brother explain what the diodes are doing.
So the diodes will prevent, basically when you have a DC motor, it's got a coil of wire in it. And that coil of wire basically will hold on to a charge and create a magnetic flux. And that magnetic flux is what powers the actual motor spinning. So then as the motor, when you disconnect the power, the motor continues to spin for a second, and that induces charge in the coil through the same magnetic flux. And that voltage is trying to leave the system. So you're trying to prevent the current from flowing backwards through the transistors or shorting to ground. So that's what the diodes are for. Yeah.
Okay. hopefully that answers your question. So here is the L293D. That's just like the product number of this little integrated circuit. And so it allows you to control two DC motors independently with forwards and backwards control. And so on the right you can see the actual L293D, like the pinout. So the top left and bottom right are the enable pins, and then the VCC1 is for that's the actual power that'll go to your motors. So oftentimes the Arduino is only 5 volts, but you might want to power like more hefty motors, so you can plug in like a 9 volt as your VCC1. And then VCC2 is used as your logic level, and that's basically what that means is each of these other like inputs is going to be some PWM signal, and so that's from 0 to 255, and that's a fraction out of the 5 volt logic that Arduino uses. And so this VCC you would want to put 5 volts because we're using 5 volt logic. But if you were using like a Raspberry Pi, then a PWM signal would range between 0 and 3.3 volts instead of 5 volts. And so then you would want VCC2 to be a 3.3 volt signal, since that's like the max of your logic level. And then output 1 and 2 are for one motor, and then output 3 and 4 are for the other motor. And then each of the inputs are for like the different directions of each motor. So like input 1 will control like clockwise of your first motor, input 2 will control counterclockwise of your first motor. And then these 4 ground pins, you can, as long as any one of them is connected to ground, that'll work. They're internally, all 4 ground pins are connected. Okay. So now let's look at wiring an H-bridge. So if you're following along on Tinkercad, you can use this little screenshot, but I will go ahead and switch to a view where we can kind of build that in person. I'll switch to a camera where you can see what I'm working on. Okay. This view should be good. Please let me know if you like kind of can't see anything. Okay. So for this, we will go ahead and put this onto our car. So this is our little car. Let me move the camera view up so that you can see it better. Okay, so this is our car, and then these are just 2 hobby motors, and there should be an exact similar product in Tinkercad if that's how you're doing it. And then this wheel is just like on a little caster, and it's used for stability of our thing. And so the first thing I'll do is I'll just get 2 wheels, and I will put them on the motors so that they actually stand up. Okay, so I will put that right here. Okay, and then the other wheel will go on this side. Okay, and so now you might be able to hear it, but when I turn the wheels, you can kind of hear the motors spinning internally. Okay, so now I just put these little wires through one of the holes in the board, and so that allows us to just like it'll be easier access to these things. And so right here is a battery pack, and this is what we'll actually use to power the Arduino. And so this can go right here facing this way. And so now I will just use a small amount of electrical tape to keep some of the stuff in place. Should be okay, I found it. So I will just cut off a small piece of electrical tape, and I'll use this to hold my so this will hold my breadboard in place, and I'll get the other one to hold the batteries in place. just sticking that on the bottom right here. And if you're building this or if you're following along, you want the cable to face from the back of the vehicle, because that'll make it easier to then like loop it back and plug into the Arduino. So in the end, we'll have our Arduino right here, and this will plug in like that. So I'll actually also just put a little piece under the Arduino to keep it on the battery pack. Okay. So here's our one last piece of electrical tape, and I'm just putting it anywhere on the bottom of the Arduino to secure it on right here. Okay. So now let's just kind of go through the steps of how to wire up the Arduino to the H bridge. And so anywhere where you see like H in parentheses, that's referring to H bridge, and then like port 1, port 9, port 16, and then A, and then something in parentheses is Arduino, and then like port 6. So it might be a little confusing, but this is not like analog 5, this is just Arduino and then digital 5. Sorry about like the wording being a little weird. Okay, so the first thing we'll do is we'll take the Arduino and we'll put the 5 volt and ground signal onto the power and ground rails of the breadboard. So right here, that's not focusing. Okay, so I will put this into the 5 volt pin and put this in the power rail of the Arduino. And is anyone unfamiliar with like how a breadboard works? I can kind of explain where the connections are. Okay, cool. And so we've connected power and ground, and the next thing we want to do is connect the voltage in. So V in on an Arduino is this pin right here, and that power is coming directly from the like whatever's plugged in. So if you have a battery right here, it would be the voltage of that battery, and then but right now it would just be the voltage coming from the USB, which is also 5 volts. And so that is going to the other power rail at the top. And then we want to just put our motor driver in the breadboard. So we already did that. That's this little L293D. And the orientation is very important. If you look, there's like a little, you see the little dot in the bottom left corner. And so that's the same as this little nub right in the bottom, or right at the top of the diagram. Okay. So now we will start wiring up all the different pieces. So the first thing is we want to connect the ground rail to the pin 13 on the H bridge. And so 13 is on the right side, or on the top side rather. So that's right here. And so we have 1 through 8 here, and then 9 through 16. So pin 13 would just be 9, 10, 11, 12, 13 right here. So that's that wire. And then now we're just going to kind of connect up a bunch of inputs. So I will use a green and yellow wire for each motor. So H2 is coming to Arduino 6. So I will put a wire in H2, that's right here, into port 6 of the Arduino. And so that will be our input 1 for our first motor. And notice that the port 6 has a little tilde next to it. Sorry about the glare, let me see if I can fix that. Oh. There we go, there should be less glare now. Okay. Yeah, so port 6 has a little tilde next to it. That means it's a PWM pin. And so that means it can send signals that are between 0 and 5 volts instead of just like only low or only high. You can go 0 to 255 between those values. And so that's coming right here. And then once those two signal wires have been plugged in, you want to connect the motor 1, ground, and power. So the ground will go to the H3, so that's right next to the green one. and the power will go right next to the yellow one. And then we want to do the same thing for our second motor, so that's we'll just do another green and yellow. So we will connect this green one to input 3, so that should be pin 10, so that's the second one on this side, and that'll come to port 10, or sorry, port 11, and then we'll have the second input for our motor 2 coming, oh sorry, I had that off screen, sorry. And so then this one is in input 4, or port 15 of the L293D, and that's coming into the PWM pin number 10 of the Arduino. And then again, we want to plug in our power and ground. So 11 gets the ground wire for the motor, so that's this black one. That's coming in right here, and this red one will come in right here. And then we want to, so I think I skipped 2 steps, yeah, 4 and 5. So that's actually wiring up the power signals for everything. And so for that, I will put in the 5-volt power rail. So we need 5 volts at 1, 9, and 16. And so if you look at the diagram, that's enable 1, VCC 1, and enable 3, 4. So we'll put one here. We will put, oh, that's the ground, so we want to make sure it's in power. And then this 5 volt comes to port 1. And then we want another power coming into port, we want this coming to enable 1 and 2, so that one will go across. I know the wires are really messy, but hopefully, like, since I'm going in order, you are able to follow along to some extent. Does anyone if anyone's using Tinkercad, are you having any issues with that so far? And then, so that's the 5-volt wires, and then I need to put the V in at the other input of at the other VCC. So port 8 of the H bridge is coming from the high power rail at the top. And so that's this one. Okay. So that is all the wiring. So first, before we move on to the MothBot, let's maybe try some basic coding for this little motor. So So the first thing I'll do is I'll just set up like my pin numbers, and so what I prefer to do is just have a little define statement for each of my motors, or each of my motor pins. So I'm just pasting this in right now. So the left forward will be pin 10, left reverse is 11, and then right forward and right reverse would be 5 and 6. And so that makes sense because, oh, I'm actually not sharing my code, so I'll switch that in a sec. But if you notice, the power pin of the motor is next to, so if you look at this red and yellow one are next to each other, so the red is the power of the motor and the yellow is coming to the 5 volts is coming to pin 5. And so pin 5, you can kind of like, since that wire is next to the power voltage, we can just assume that would be the forward rotation. However, if the motors were like mounted backwards, you would want to reverse like which one is forward and which one is reverse. But yeah, let me switch out the views so that you guys can see my code. Okay. So now you should be able to see the code. So you can see the top left, I just did a bunch of defines for what each of the motors will be. And then now I will go ahead and set the pin mode to output for all of them. So pin mode of pin motor left will be out, output, and then so we want to do that for the reverse. And we want to do it for the right side as well. Okay, and now I will just paste in a little helper function that I made. So let's find that. Okay. So now let's go right here. And I will paste that. And can you see the whole method in there? Yeah, okay. So this method is setDrive, and so we basically just abstract the logic of like setting, like writing power to a different pin, because like for how the H-bridge works is like you set high voltage to one, or you set high voltage to the other pair of transistors. So we having that in our code everywhere would be kind of cumbersome. So what we instead do is just allow negative 255 to positive 255. And then for the left motor, if it's negative, then that means we want 0 on the forward power and negative left on the reverse power. So it's basically just going to take the value of left and apply that to the reverse pin. But then if left is positive instead, then we'll just put that power on the forward and set the reverse motion to 0 for left. And then we just do the exact same thing for our right motor. And that basically just gives us a much more clean way to set the power of our motors. And so now what we will do is, so our loop, we won't have anything in the loop, but we'll just do setDrive, and we'll do like 100 comma 255, or actually let's do negative 100. And so that'll make the left one spin negative 100 and the right one spin positive 255. And let's try to send that to the car. So this should, okay. So that means something is wired incorrectly. So let's maybe add in a let's try this. Okay. So something, I must have messed up the wiring somewhere. So let's try to look through and see where we might have gone wrong. Okay. So the first thing I'm checking is the power rails. So we have the 5 volt and ground. Yeah, so the 5 volt and ground are coming to the ground and the power rail at the bottom. And then we have our 5 volt signal coming to 1, 9, and 16 of the thing. I'll just check this with my reference. Oh, I think I know the issue. So we forgot one wire. We pulled in a ground. So right now we're using this. Oh, I don't have it in view. Okay. Right now we're using this top ground rail, but this top ground rail only has like the thing plugged into it. It doesn't have anything actually like pulling it down to ground. So what we need to do is we need to put in a wire right here. And this white wire will just connect the two ground rails, and that will make each of our, that basically just makes the ground rails actually be ground rails. Since this ground rail was actually tied to ground, but this top one was just floating. And that's why the L293D had no ground reference, and that's why it was just not spinning anywhere. And so you can see the right motor is spinning in the negative direction, and our left motor is not spinning. Okay. So it looks like we have some debugging to do. So right motor is set to 255, but if you see, that's actually the reverse motion of what we want. So then we need to just switch this right and left. So this is reverse. This is forward. And so I will just have to hold this up since it's not stopping. And then for some reason our left motor is not spinning how we want it. So let's check these two wires. These are all plugged in correctly. This is kind of strange. I'm not sure exactly why okay. It might just be a weak battery, that could be why, because it seems like this, so the issue is that this left motor, the batteries are really weak, and since I only put 100 power, like if I give it a spin, it'll like kind of continue and then it'll stop, so it just doesn't have enough power to keep itself spinning. And so if I do negative 255, we can actually see that it should spin if I give it full power. And for now, we'll switch out the batteries and make sure it's working. Okay, so yeah, now you can see that the left motor is actually spinning. It's just that the battery voltage is too low, so 100 power wasn't enough for it. And again, we're putting a negative value, but it's spinning the opposite direction. So we can just switch around our reverse and forward pins. And that'll fix that. Okay. So now we can go ahead and start building our MothBot. So let me switch to another camera view. So what we'll do now is we will add a photoresistor to the car. So we'll put a photoresistor on each side, so we can put one on like the left side of the car and one on the right side of the car. And basically what that'll allow us to do is just detect the difference in light at each different photoresistor, and then based on that we will either turn left or turn right. And so before we get started, I'll just point out a couple links. So as usual, Tinkercad as usual, if you want to try to build it yourself with Tinkercad. And then there's the car kit, so that is just like a little kit to build this exact thing. It's on Amazon. That's the link is right there, and Jack should be putting it in the chat soon. And then if you want to look at already completed code, you can also look at that link at the bottom. Okay, so first thing I'm going to do is unplug this so that it stops trying to drive away from us. Okay, so let's get started. So I will go ahead and switch back to a more useful view. Okay, so we want to add the transistors to our car. And so the way we will do that is we want to have the resistors pointing kind of forwards. So what we'll do is we will plug it in to two different rows of the Arduino, or of the breadboard. So let me bring this camera back down. Okay, so notice how that's in like two different rows right here, and then we'll just kind of bend it so it's pointing forward. Okay, and then we want to do the same thing as before. So we want to plug in one power for that, for the photoresistor. And I actually want to use shorter cables, so what I'm going to do is I'm going to switch out the cables that we're using for our rails. So here I will just use the longer red wire to get to each rail. So let me try to get a view that sees everything. Okay, so here I'm just switching out to a longer wire. So this one is coming into this 5-volt rail, and then this wire will come in from our V in to the far side rail. And so now we have these two shorter red wires to play with. So I will connect the power pin to the this rail of the photoresistor, so that's the right side rail. And then I will take a resistor and I will just go straight from this pin to ground. So I'm just going to plug it into that same, like the second column right here, and then I'm just going to plug the other end of the resistor into the ground rail. So that's just like that. And then we also need our signal cable. So for that I'll just use this blue wire. So that's also coming from this second column of the photoresistor, and I'll just bring that to pin A0. I can choose any analog pin that I want. And then we'll get our other photoresistor. And so I will just straighten the pins out and then put it into the breadboard. Just like that. And point it forward. And while I'm just like kind of doing and talking about the wiring, does anyone have any questions? Okay. So I will take another power wire, and this time we can't use this top rail because the top rail is using like high voltage that's coming from the battery. So we don't want to use that to power the photoresistor, otherwise the photoresistors will have two different power levels. So for that I will just grab a longer red cable and go over this little gap. So that'll come from this power rail, which is a 5-volt rail, and that'll connect right here to that first column of the photoresistor. And then we want a resistor to go from the other side of the photoresistor just straight into ground. And then our last cable, we'll just use a little green one to be our signal, also from this second column on the photoresistor to one of our analog ports. So we will just use analog port 1. And so now we have fully wired up photoresistors the same way that we learned about earlier. And the last thing we'll do is we'll create like a failsafe, or kind of like an on-off switch. So this is a very basic on-off switch. You could instead use like an actual button or an actual switch. But what we will just do is we will wire the port 2 of the Arduino, and we will just wire that into ground. And so what that'll do is we will read a signal from port 2 on the Arduino, and if that signal is ever high, then we'll just like cut off the motors. But if it's low, then we'll like do our little analysis of which side is brighter. And so now what you can do is, since you have these two photoresistors right here at the front of our car, right now they're kind of always seeing a similar light level. So what you can do is find like a little divider and put that in between them. So right here I'm just using a sheet of acrylic with the cover still on, and so now light that is coming from here is going to be kind of obstructed by this acrylic, so it won't also reach this photoresistor. So now let's go ahead and try to write some code for it. Cool. So the first thing I want to do is put in some define statements for my photoresistors. And so that'll go right here. And so our right photoresistor is this one, and that one is this blue wire coming to a 0. So we will just make that 0. And then this left photoresistor is in this green wire coming to A1. Oh, that's an exclamation. Cool. And then next thing we want to do is set the pin mode for both of those to input. So let's quickly do that. So we have these two photoresistors are our input, and then those 4 other ones are for our output. And so now I will just create a couple constants that we'll use for our control. Like these will kind of just be like hyperparameters of our like motion control based on the light levels. So we'll make a min light level, and so what this will be is the min light level for the vehicle to move at all, and we'll just set that to 0. But if you were actually building this in practice, you might want to make that higher. For instance, like if in ambient light, obviously the sensor is going to be over zeros, but maybe you only want the motors, or you only want the car to drive when there's like a very bright source of light, so you can increase that min light level. And then we will also define a max light level, and so this isn't exactly what you might expect it to be. This is essentially just how like at what light level is it just like full power. So at any light level equal or greater to 800, we will just send full 255 volts to the motors, or not 255 volts, that would be insane. We're just going to send a full 5 volt signal, which is just 255 in our PWM. And then the next thing we want to do is we want to create some thresholds for when we, sorry, this camera is a little bit off center. Okay, so next thing we want is some thresholds for like the difference in our two light levels. And so we will just make a threshold of 100, and you'll see where that threshold comes into play once we start writing the actual code. And so this will be 100, and then there's also two last things that I chose to use, which is kind of the minimum and the maximum turning, or sorry, the minimum speed and then the turning. So this min speed is just 20, so like the motors will always have like a tiny bit of speed. And then this max turn is basically just how strong of an influence the difference in light level will have. So if you change this to like 100, then even an extreme difference in light level will still not cause it to turn that much. Okay, so now we have kind of all of our setup in place. So now let's kind of put some stuff together. And right here, how about we just start by setting the drive to 0, 0. So we'll start in the stopped position. Okay. So now we want to check, so the first thing we want to check is our failsafe. So if, and then digital read. So this is how you read from a digital pin. And then pin 2 was the one we used for the failsafe. So when we just put like a digital read inside of an if condition, then that'll just do like, if it's high, the if condition will run, and if it's low, then the if condition will get skipped. So if it is high, we want to set the drive to 0, 0 because we want to stop all motion and then just return. We don't want to do anything else. Okay. So now the first thing we'll do is grab the values from our two photoresistors. So that is, photo left is just going to be analog read from photoresistor pin left, and then right is the same. And then for the sake of debugging, we will also go ahead and add some print statements. And so I'm about to paste these in. So notice how I'm not using println, I'm just using print. And that's because we're going to print a series of data values all related to like the same run of the loop. And that way each row inside of our serial monitor will be like a single like collection of values. And so the next few lines are going to be a little bit confusing. I'll try my best to explain what they mean. So let's paste them in right here. Okay, so forward power is going to be, so you guys can, let me switch to a different view that doesn't have the car so that you can see the entire code. Sorry about that. This one, you should be able to see all of it. Yeah. Okay. So our forward power, so the first thing we do is we are mapping the average light level. So that's this, right? And then we want to go from So the way the map function works is it takes in a value, and then it takes an initial range, and then like an output range. And so we want to go from min level to max light level. We want to map from that range onto 0 to 255. But because we have like some minimum speed, we also subtract the minimum speed from like the max of our little light level range. And so then this, from map until this little thing, is going to be it's going to range between 0 and 255 minus min speed. However, we also want to constrain it, because if the average light level is above our max light level, which is kind of just like our max throttle type of thing, if that average is above it, then the output of this is going to be above 255 min speed. And so to resolve that, we constrain it, and then so constrain takes in a value and then a minimum and a maximum, and so then that's just used. We again set the minimum as 0, and then this is just so that if it's above it, it'll get clamped back down, and then here we are just adding back our minimum speed. And then next thing we do is we want to figure out our turning power, and so that is just going to be based on the difference left minus right. And then here, this is somewhat arbitrary, but this will go from, oh actually, I think I made a typo in this code. This should be that threshold value. And so let me just go ahead and change this to 300 so it behaves like it did in my tests. So this is going to go from negative 300 to positive 300, is going to get mapped to the maximum turning power. And so then again, we map it and then we constrain it just to make sure it's correct. And then this VW, L, and R is an algorithm that you can find online, and it's basically just a way to go from a certain amount of power in the forward direction and then a certain amount of power in the turning direction. So you have like two axes of control. It'll convert that into just like a left motor power and a right motor power. And so that's what this V and L is used for. It's just implementing that little formula. And so if you want to look up or kind of understand more about the formula, you can probably look up something like two-axis control or like two-axis joystick to tank control. So tank control is when you have like a left and a right power, and then two-axis joystick is like you have one axis controls like your forward power, and the other axis controls how much you're going to turn. And so then once we compute all of those values, we will again give us some print statements to kind of just see what we expect the motor to do. And then finally we will set the actual values to the drive. So we set the drive with the left power and then the right power, and then this is just a delay 100. So you usually want a delay in your Arduino code just so that the CPU isn't getting overworked calling the loop function over and over. And then this last print ln is to actually like move to the next line after we've printed all the data that we care about. And so that should be all of the code. So let's go ahead and try to compile this and download it to the robot. So I will just plug in the robot, and then while it's downloading I will switch to a nicer view. Okay, so it looks like because I unplugged the board, we'll just have to reselect thing. Yeah, okay. So now it's downloaded. And so what I'm doing is I'm just putting that port 2, I'm just putting it into the power line so that it won't try to drive while I get stuff set up. Okay. Sure, we will do this view, and I will just move this camera up. Okay. Okay. So now we can, actually I will find a screen that has the serial monitor as well. I don't know if we have a scene for that. Sorry for the delay, I'm trying to set this up on the fly. Okay. So let's go ahead and look at this. So here we see our serial monitor and then our car. So if I take this wire, this port 2 wire is currently in the power rail. If I move it to the ground rail, you'll see that the print statements start running again. And so they're both trying to move forward. You see that the right side is a little bit higher, that's why this one's moving. And this one is still very slow, it tries to... Okay, so I forgot to switch the batteries out, so let's quickly do that. So we'll just pick this up, we will move that battery holder, and then I will grab this battery holder which has refreshed batteries in it, and stick this down. Now it should be more willing to move. So yeah, now you can see I think there might just be some issue with the left motor being bad, and that's why it keeps stopping. But yeah, so now let's try to make it switch directions. So if I put the light on the left side, then it makes sense that the right motor should be spinning more to reach the left side. And if I put it on this side, it makes sense that the right motor should be slower than the left motor. And so in the print statements you can see that the left motor is at 255, but I think we're just having some issues with the board. The left motor doesn't want to spin properly. So, okay, I think what I'll try to do is use the circuit I made before this demo just so that you guys can actually see it in action. So I will need, so we have this vehicle right here, and I just need to add in a wire that I stole earlier. So this is just, I took the power wire earlier. And so this one should be working correctly. Yeah. So this one actually has power. So when the brighter light is on the right side, the left wheel spins faster, and when it's the other way, okay. So you see how the left did slow down, but I think this one might also be having some issues with the motors. Yeah, so now you can see the right one spinning faster. I think what might help is turning the lights off. So does anyone have any questions before we move into kind of like a final demo? If anyone was following along, do you have questions or? The light on. So yeah, you can see right now they're going about the same power, but with the lights off, okay. Yeah. So I think there just seems to be a couple small minor bugs in the code that's making the motor stop. But in general, it is going towards the brighter light. If I put this on the floor, we can. I can try to get the camera to show you. Yeah. So you can see that it's kind of turning towards the light. What is stopping? Let's put it back right here. And so when it's here. So yeah, I think there just might have been a small bug with like the minimum light levels, but hopefully you were able to see it kind of turning towards the brightest one. And yeah, and so we'll just turn the lights back on. But yeah, so that was hopefully a simple enough demo that you could either follow along with or you think you could kind of recreate on your own. And so let me just put the failsafe back in power so that it turns off. Yeah. So, does anyone have any questions about the little MothBot that we created? The word moth is because it's chasing the light, if it wasn't obvious. Cool. Seems like there's no questions, so let me just switch slides. Let's just go to this. So next week on Thursday the 25th, we will have our second project meeting. We will be going into a little bit more depth on the planning of the robot arm that we're going to be working on this semester. We're actually already getting started on just 3D printing a couple of the parts, and that way we'll be able to jump right into more serious development on Thursday. And if you want to, you can also, we might plan like a quick meeting this Thursday as well, perhaps this Friday. Just check out the Discord for details. Yeah. Thank you everyone for coming. Bye.